Good morning or good afternoon, depending on where you're tuning in from in our work from home world, as I imagine most of you are. And welcome to today's masterclass in handheld 3D scanning. This webinar will take us through an overview of DotProduct technology, relatively brief, and transition into not one but two live demonstrations of our Dot3D Pro software at use on two different hardware setups, showing the capabilities and highlighting the best practices of what can be done with handheld 3D scanning today. We will be taking any questions via the GoToWebinar interface. Please feel free to submit those at any point throughout the session, and we will take them one by one at the end. Please also note that we're going to be transitioning between multiple devices throughout this session. And bear with us if there are any technical difficulties. Hopefully that's not the case, but we're doing everything completely live as we always do with our DotProduct workflow webinars. So first off, I'd like to introduce today's presenters and instructors for this session on handheld 3D scanning. Myself, I'm Chris Ahern. I am based out of my home office here in Boston today, and I'm the marketing, sales, and product manager here at DotProduct. My colleague, Tom Greaves, will also be joining from his home office in North Andover, Massachusetts, and will be leading the DPI-10 demonstration, highlighting our flagship product at use for indoor scanning. I'll also be transitioning to a live demonstration myself, capturing using an Intel RealSense depth camera. First, we're going to walk through a brief presentation, and then we'll switch over to the live scanning. So this first slide here is basically just to give anybody on the line who's in any way new to our technology a very brief overview of what we do, highlighting what we're achieving across all of our platforms and what we're aiming to capture with our current solutions. So DotProduct handheld 3D scanning is providing a truly mobile solution that allows you full freedom of motion to walk around the objects of interest. Very simple to use technology. I'll be highlighting some advanced features today. It's also worth noting how easy and usable our technology is with the user interface designed for field workers in the field. Our solutions are all completely handheld, so self-contained devices operating on phones and tablets, and inexpensive at a $2,000 to $6,000 all-in cost for hardware, software, everything you need to start scanning for the full spectrum of our product line. We're producing accurate results with engineering grade data in a variety of environments and giving you real-time feedback on the quality of the data you're capturing while you scan. So before we move over to the primary portion of this session, which will be focusing on the Dot3D software itself, the functionality, and the scanning live, I do want to touch base on some of the different hardware options that you have at your disposal today and all the different ways in which Dot3D software can be deployed as a handheld 3D scanning solution. So in our latest releases, we have the DPI-10 and the DPI-10 SR. These are our flagship handheld 3D scanning solutions compatible with Android and Windows devices and multiple different depth cameras, which I'll touch on shortly. Our latest Dot3D software, which will be running on both devices we demo today, is the Dot3D Pro 3.3 solution. On the DPI-10, we are now supporting two different flagship tablets. On Android, we have the Samsung Galaxy Tab S6, and on Windows, we have the Microsoft Surface Go. It's important to note these two tablets are a major improvement over our past models because of the specs built into each device. In particular, each device has 8 gigabytes of active RAM or memory, which allows capture of larger and larger scenes versus our past models. So you can scan a very large interior or exterior spaces, depending on whether you're using the built-in calibrated DPI sensor or the attachable RealSense camera. And as you see in the images here, we're scanning much, much larger areas per scan.
Yeah, so Chris, let me jump in on this one. This is one of the largest scans that I've seen our customers do. It's the deck of a ship, and it's 157 megabytes. So one of our dealers up in Canada captured this, and you can see the use of AprilTags in there. It's a large scene, but it shows the sort of upper limit of what can be done in a single scan.
So in addition to our DPI-10 tablets, which are recommended not only on the DPI-10, but even as standalone tablet solutions with RealSense cameras, we're supporting a full lineup of Android and Windows tablet solutions. In particular, our partners at DT Research and Mobile Demand are offering rugged Windows and Android tablets, and even rugged RealSense cameras built into these devices, which makes for a great complete kit when paired with Dot3D software. The DT Research DT301X in particular is a powerful rugged tablet that's actually built the Intel RealSense camera fully into the rugged design, and also offers an optional high accuracy GNSS sensor, which allows you to tie into your GPS location while scanning, which is a powerful and exciting new feature for Dot3D. In addition to all of these supported tablets, I also want to note that we're now 3D scanning from our phones right out of our pockets. We're supporting Android currently, and a wide range of today's modern Android phones, from the Samsung Galaxy lineup to the Google Pixel lineup and more. What you see here in the image is actually what I'll be doing my scanning on today, which is my Android phone right out of my pocket with an Intel RealSense D415 depth sensor attached to the back. In addition to touching base on the tablets and phones that are supported, the hardware, the second component of the hardware when working with Dot3D software is the sensors themselves. So Tom will be demonstrating today on the DPI-10, as you see on the left here. This is our flagship model with a 2 to 12 foot range, ideal for indoor capture, although also compatible with the RealSense as an add-on for outdoor capture. The DPI-10 SR is just the shorter range version of that model with a 1 to 6 foot range for extremely tight spaces or more equipment and object-based scanning, while the 10 is a bit more versatile for a variety of environments with that 2 to 12 foot range. In addition, we are now supporting the Intel RealSense camera, as has already been touched upon a couple times in this presentation. And this has a lot of benefits on top of our existing DPI cameras in that the form factor, the compatibility across platforms, including phones, the price point, it's a very affordable solution, and the daylight capabilities. So when I switch over to my section of the scanning here off of my phone with RealSense, I will be scanning outdoors because this is by far our best supported sensor today for scanning in bright sunlight, given the nature of the technology built into the device. On top of the DPI sensors, the full lineup of RealSense cameras, which does include also not just the D415 that we're showing today, but the D435 and the D435i. We're also developing towards supporting more and more sensors. The Dot3D platform is going to continue to offer more and more options for the right job in certain scenarios. And we're excited to see new cameras coming from Intel RealSense, other partners, and more. So please stay tuned on that front. On that note, we have a quick little video here from our partners at Intel, which is showing one of their up and coming new cameras being utilized with Dot3D Pro. So please stay tuned from us and from Intel as we expect to be adding more supported cameras in the near future.
So this is the Intel RealSense 515 LiDAR sensor.
Lastly, on the hardware side, I did want to touch base on our new light kit. This is for capturing in very dark or dimly lit environments and is compatible with the DPI-10 for use with both sensors on that platform. It's from our partners at Fox Fury, and it's an improvement over our past lights, given that it is a rugged design with a hot swappable battery pack that allows you to extend your battery life in the field and continue charging between scans. It also is implemented with a convenient cold shoe mount, so it slides right onto the new DPI-10 design very easily. Before we switch over for some comments from Tom and then right into the live scanning, I do have a couple more slides to touch on here that we want to highlight for anybody who's putting together their own RealSense kit out there, the components you need and some important notes to remember when you're creating your 3D scanning system. So first off here, you need to source your RealSense camera itself. So as mentioned, we recommend the D415 as the best solution of the currently available RealSense cameras for scanning indoors and outdoors, even in bright sunny environments. We do support the D435 and the D435i as well. However, for 3D scanning purposes, we are getting the best results from the 415. This camera is available directly from Intel for as low as $150, or in a kit from DotProduct, which includes custom calibration, a magnetic mounting kit, and USB-C to C connecting cable for $500. Secondly, you need to source a compatible tablet or phone. So this is Android or Windows platforms today. And one very important note as you're reviewing the spec on each device is to make sure that your USB port is USB 3.0 compatible. This is a requirement for use with any of the Intel RealSense cameras. The third component you need to source is a connecting cable. And the fourth is your mounting kit. Both of these would be included if you bought your RealSense through DotProduct directly, although we also encourage customers who already have their own cameras or buy through RealSense to source the same recommended solutions that we utilize in our kits. So option one for your cable would be to utilize the included cable that comes with your RealSense kit, even from Intel, which is a USB-C to USB-A. However, this might not work with your phone or with most tablets, although it will typically work on a Surface Pro device, for example, that has that standard USB connection. For other devices, you most likely will need a USB-C to C cable, which is included in the kit from DotProduct or can be otherwise procured separately. It is again important to make sure that this cable supports USB 3.0 or higher for compatibility with RealSense. And we recommend visiting our knowledge base at dotproduct3d.com for some recommended cables, which will avoid some troubleshooting if you're trying to source the right cable yourself. Just go with the ones that we've already tested. In terms of sourcing a mounting kit, again, this is an option that's included in the DP calibrated kit. Or you can actually purchase separately a mat kit that includes the magnet and the cable for only $30. So that's one option. Otherwise, you can set up your own attachment mechanism, whether it's magnetic, Velcro, etc. And it's also important to note that if you go with one of the DT Research or Mobile Demand solutions, this sensor will already be built into your rugged tablet, and you won't have to worry about any of these mounting mechanisms, etc. And the fifth and most important component of setting up your 3D scanning kit is the Dot3D Pro software. And this is what we're going to be covering for the rest of today's session, live in action. And it is available starting with a free 14-day trial to get you up and running with your device and make sure that it achieves everything you need for your solution. And it is definitely what completes the package in terms of hardware and the software that you need for 3D scanning. So with that, I'm going to go ahead and pass the presentation over to Tom to touch base on some safety best practices and switch right over to a live demonstration of the new DPI-10 handheld 3D scanner.
Thanks very much, Chris. So before I bring you to my basement in North Andover for a live scan and some masterclass on scanning techniques, I just want to have a brief word about safety. Safety considerations for each job vary a lot by the job. This shot shows a tugboat that Chris and I were on a few weeks ago, and we were on the water going down into the engine room. And life jackets are required, boots, hard hat, glasses, gloves, and so on. Obviously, that's one scenario. Another scenario is you're doing some work in an apartment for an interior design project, and obviously the safety requirements are different, but please make sure that you have the correct PPE. There is an element of handheld scanning that has a unique safety requirement, and I'd like to stress that. So Chris, if you could advance this to the next image. Okay, so the thing about handheld scanning is that your attention, your eyes are necessarily on the screen. That is, you're looking at the data live in real time, and that's one of the key values of a handheld scanner, is that you can do that. But what that means is that when your eyes are on the screen, they're not on your surroundings. And if the footing for you is a little challenging, like it is in this case, I'm down, we've got the diamond plate lifted up from the engine room, and walking around requires my full attention. So, there are a couple of things here. Please maintain your awareness of the scene and make no sudden moves, particularly when you're looking at the scan. Know where your feet are, know where they're going to go. And also, many of the scanning operations can be done with one hand. So, one hand for the scanner and one hand for you. So just please keep that in mind. We don't want anyone getting hurt using our technology. Okay, Chris, if you could switch me to, I want to show everyone the environment where we're going to be scanning today. So welcome to North Andover. This is my basement. I've lived here a long time. My family and I've been here for more than 20 years, so there's a lot of clutter, but this has some resemblance to some of the industrial environments that we're in. That's my furnace. Got a small vessel there, water heater here, some piping, and we're going to capture this and use this as an example to illustrate some of the techniques that we've learned for getting the very best possible data. So just wanted you to have a look at what we're going to be capturing this morning. That's the hot water heater. We'll leave the bicycles alone. Okay, so that's the environment. Apologize for any sudden motions. Chris, if you could switch me over to the scanner now, please. So what I have in my hands is a DPI 10 with a Fox Fury light kit attached to it. And we're going to capture a new scan. So you can see the light. And so I bypassed the warm up here. We can talk about that a little later. In the upper right-hand corner, you'll see a camera image. This is from the high-resolution camera on the tablet. So when you start a scan, best practice is to have some green in the start button on the right-hand side. This is telling you the scene fitness, how much geometry, if the geometry is sufficient for the device to track. So the way our handheld scanners work is that we use the geometry of the scene and the textures, the colors in the scene, to track the location of the camera. That's a critical part of being able to stitch the data together that we capture. And the green circle around there tells you whether you're in a good place to start. So I'm just going to tap it and we'll start. And you can see we have that real-time feedback. We're painting the scene green and yellow. And anything that's green or yellow, we've captured. So I'm going to demonstrate a couple of features that we use in some specific locations. On my lower left, I have an airplane icon, and I'm going to select that, and it picks a plane up. Okay, it found a plane on the floor of my basement. And I'm going to do that again over here. Okay, it finds the same plane, and what the software will do is use that as a constraint. It will force those two areas of the scene to be in the same plane. Now, obviously, this makes no sense if you wouldn't use our device to measure, the flatness of a concrete floor. It's not designed for that. But if you do know that you've got flat walls, this can be very helpful for improving the quality of the data you're collecting. It's an additional constraint. So we're going to be hitting that button a couple of times here. Next, I'm going to take a photo of this water heater, and I'm going to hit the camera icon on the right-hand side. Okay, so that's using the tablet camera to take a photo. And because we're also doing this while we're scanning, we know the 3D location of that photo. So I'm busy here. I'm going to capture a scale bar here. It just lit up. This is from our Brunson scale bar AccuScale kit. We're going to go and capture the other end of it here, and it'll light up. And it's exactly 1,200 millimeters between centers. I'm going to take another photo right here of this equipment tag. All right. One thing to keep in mind about lighting, I've got the Fox Fury light kit mounted on the front of the device, but there's also some ambient light behind me, and this can create shadows. You'd really like to avoid that. You want the scene to be lit in front of you rather than from behind you, because as I mentioned earlier, we're using the colors and the textures in the scene for tracking. And if you're creating a shadow while you're scanning, you can confuse the sensor. I'm gonna go up and get some of this piping. I'll take another, oh. There, it got lost momentarily. I took it back to an area where I was previously, and the camera relocalized, recovered its tracking. And I'll take a photo here. Those are the valves. And I'm going to go back into a very dark, poorly lit corner, dusty corner of the basement. And there's the water valve. I'll take a photo there. And we're going to stop the scan here. All right, so this is the raw scan that I've captured. And the first thing I'm going to do, I always do this. I always save the raw file. So we're going to save this raw file, and we're going to call this basement one. Oop. I'm going to just label that raw A. Okay. I always like to be able to get back to the raw data that I've collected. So we'll save that. And then the next thing I'm going to do is optimize this scene. And the software recognizes that I've set some plane parallelism constraints. Those are the flat planes that I picked. It's found some AprilTags automatically, and it will use those for loop closure. So a very good practice when you're capturing data is to do a loop, to do a 360-degree loop around the area of interest. This can reduce sensor drift and improve accuracy significantly. And AprilTags assist with that. We've also got a Brunson scale bar. So I'm just, without further ado, go and hit that. It recognized the red scale bar, 86.61 inches, which is 1200 millimeters, and we go next. So it's going to process that scene. Just takes a couple of minutes. One of the big advantages of scanning with handheld devices is that we can have a look at the data right in the field. And there are a number of projects that we've been involved with where the data we've captured the data in the field and then we send it to the back office. I'll show you how we do that in a minute, but it's a key advantage being able to look at the data immediately after you've captured it and then be able to share it with someone who may be, halfway around the world. Okay, so it's just finishing up on the optimization. This Surface Go tablet has double duty. It's presenting the webinar and it's also processing point clouds. So we've got two modes for inspecting the data. I've got the surface mode, which is the camera, or which is not the camera, the icon in the upper right-hand corner. I can toggle that. And when I toggle that, we go into a rendered mode. I actually prefer using the point mode, but some situations it's helpful to have the rendered mode. So next, what I want to do is look at some of those high-res photos that we took. So we're going to go view high-res frames. So I have a gallery of images here. I have 4 images. And in the point cloud, you can see 4 camera icons. They're those purple camera icons. And each camera icon corresponds to the photo. So if I select the photo, it pulls up the corresponding image in the gallery. All right. So this shows us that we know where each of these photos was captured. So if I can go the other way too, if I tap the photo, it will take me to the place in the point cloud where I captured that photo. So this is designed for walk down workflows. So you can see where you've captured the photo. And for 3 or 4 photos, it probably makes no difference. But we have customers that we might take 300 or 400 photos. And a week later, you've handed this point cloud or a gallery of photos on a thumb drive to coworker, and if they've never been to the scene, they're going to have a hard time locating those photos in the scene. Here we have the situational awareness. Now, I'm going to do a long press on one of the photos, and you can see the level of detail that we get. You know, you can read equipment tags here. I can't read that font from 3 feet away with my, with my glasses, but I can sure read it on the image from the camera. And here's another one. Okay, so that's a CH412. If I get a little closer, I can even do a better job on those photos, but this is ideal for capturing equipment tags. We see some opportunities to capture barcoding in the future. All right, so we've got this high-res photo feature, and yes, we export these photos as JPEGs and with their XYZ coordinates. So let me go back to some other things that we like to do in the field that are good practices. One is the very near the beginning, we like to set up a coordinate system. So I'm going to go Edit, Coordinates, and it has automatically created a coordinate system. Sometimes it does a really good job, like this time it did a really good job. Most of the time it does a really good job, but we may want to set our own. So we're going to go Set. And if we know a coordinate already, let's say we have a CAD model or a piping model, we can assign a point, a value from the CAD model. We would do that by setting a coordinate, and we just enter the XYZ values in whatever units make sense and pick the point. I'm going to bypass that and just pick an origin point, and I'm going to set the origin here. And I've got this little magnifying glass in the upper right-hand corner that allows me to, have a pretty fine pick of where I'm going to put that point. I'm going to put it right next to that case. And then we have to set 2 planes. Well, I'm going to set Z perpendicular to the floor, and it will create a vector and set Z perpendicular to the floor. And then another logical step would be to set X or Y. We'll do Y this time by just selecting Y. And I'm going to make Y perpendicular to the wall. Okay, so I've got Y coming out of the wall, and we can see that there. And then we confirm that. And we could easily set that as X, and we can also toggle the axis direction 180 degrees. So there we have a coordinate system. We've optimized this file. Good time. In the upper left-hand corner, you'll see a yellow pencil. And that yellow pencil is telling us that what we need to do is we have unsaved changes in this scene. So I'm going to save those. File, save, and we're going to save it as in the user coordinate system. There we go. All right, bad me. I should have given that a new name. My apologies. No worries though. We have that raw file stored elsewhere on the drive. We can recover that. But I ought to have renamed it because we've optimized it. So next thing we can do is take a measurement. We've set up a coordinate system, and I'm going to show the distance measuring tool here. And the way that works, we pick a point in the scene, and we've got that little magnifying glass up in the corner. So I'm going to pick a point there, and then I'm going to pick another point over here, and I can just move this measurement point around, but I'm going to go back to the center of that target. And there we have the change in X, change in Y, and change in Z, and also the point-to-point distance, the spacing between those measurement picks. Okay, and we can move this around. So we can get measurements right away in the field. All right. So another thing that is very useful to do in the field is to annotate the scene. So we're going to make some annotations here. So I've selected the plus key for the annotations, and now what I need to do is pick a point. So we're going to pick a point here, and I've got that magnifying glass. So this is going to be a point annotation, and we're going to key in, water heater. And we could make some notes, you know, needs to be replaced, show signs of leaks, you know, not at my house, of course, but, you know, you might come across some corrosion, something that you want to make a note to yourself for attention later. And we've recorded the XYZ coordinate of that annotation. All right. And then I'm going to go and make another one. And we're going to pick this. This is going to be another point annotation. And this is going to be the scale bar kit case. Oops, I lost a C there. Let me try that. All right. I could also set a web link there if I had it, a URL. That's something we would more likely do back in the office. There we go. Okay. So now I've got two annotations. All right. So I can send this file like this back to headquarters, and it will have those annotations in it. I can also add more annotations. Let's say I've got a DSLR camera, and I want a very high resolution example of that. I can select photo and pick a photo annotation there. Okay. So the thing is too, when the user gets back in the office, gets these photos, they have the opportunity to double click on them and be taken to the place I was when I made the annotation. Okay. So these annotations are exported as a CSV file for use downstream, and they also can be used, to communicate, to tell the story of this scene with elements that are most visible to the person on site. Okay, so there we've captured this scene. The last thing I'm going to do here is I'm going to save it. We're going to go File, Save, Save. Now, how do we get this data back? Well, we've saved it. I'm going to open up Dropbox, and I'm going to upload it to Dropbox. So I created a folder yesterday, and we're going to upload that file that I just took. And, it's similar for, other sharing applications that you use. And I go and find this file. There we are. Open. And it's saving it. So now that file is available to Chris because it's in Dropbox already. It's that fast. That was only a 12 megabyte file. So the last thing I'm going to do is show some other workflow opportunities. We can export this file export. And here we have a choice of point cloud formats. And I want to draw your attention to a couple that are fairly recent for us. We can export a recap file, an RCS file, directly from the software. So you don't need to open recap to create a recap file. You can export it directly from the software you use to capture the file. Similarly, in the world of Bentley, we can export a POD file. And I understand that for Siemens NX, they can use those same file formats. We also support industry standard formats like ASTM, E57, PTS, PTX, LAS, LAZ, and so on. But this is a way to get the data from the device, downstream to where it's really going to be used. Okay, so that's a quick romp through some of the more advanced functions that we use. I'm hoping that some of you will have some questions. I'd be happy to answer them afterwards, but I'm going to pass the baton back to Chris, who's going to continue the story outside his home. So over to you, Chris.
Great. Thank you, Tom. You should be able to hear me now, checking in this time from my phone. I'm going to go ahead and switch the presenter over to my Android phone, and we'll do some more scanning from a smaller package. So you should now see my screen of my Samsung Galaxy S9 Plus. And as mentioned before, one of the highlights of the RealSense camera that's attached to the back of my device is the daylight scanning capabilities. So I'm now headed outside to do some scanning in daylight. I've opened up the same Dot3D application that Tom was utilizing, and this application really is the same across platforms. Virtually the only difference between Windows and Android versions are a couple export formats that are only available on Windows. I'm going to go ahead and press Start Scan. And now I'm connecting to the RealSense that's magnetized to the back of my phone. And I'm ready to start my capture session. While Tom gave us a great overview of a lot of the functions and features available to you during scanning and after the fact, I'm going to be specifically focusing on some new workflows that we have using our AprilTag targets and capturing larger scenes using the latest hardware and software. So as always, we're going to start at one AprilTag that I have laminated and taped to the ground here, and go ahead and move throughout my scene. You see the same real-time feedback in green and yellow showing you the quality of every area that you've captured. And I can utilize the same plane picking functionality as Tom did earlier. I've strategically placed a minimum of 3 AprilTags in my scene, as I'm going to be highlighting the AprilTag registration functionality. Whereas if you're scanning multiple areas and you need to link them together very accurately, you can do so utilizing 3 targets that overlap between scans. So once I'm happy with my scan area and I've turned all of my AprilTags nice and orange, I press finish scanning, just like Tom did earlier. So what I'm going to highlight here is a very powerful feature when scanning larger areas or when you have particularly tight accuracy requirements. It can be especially beneficial with the RealSense camera, which isn't quite as precise, clean, and accurate as the DPI that Tom was using earlier. So before I optimize the scan, I'm going to quickly reference a known measurement. So I select optimize and then set target coordinates. And I took a measurement of this area that I'm going to be scanning from AprilTag to AprilTag. This was as simple as pulling out a tape measure and measuring the distance between 2 targets. And while this is a quick sample scan as part of this abbreviated live demonstration during the webinar, this feature is particularly valuable for larger area scans. While your data is going to be very accurate in its own right, even without any targets for short area measurements, you can, really tie it down nicely for larger areas if you reference some measurements. So I want to use AprilTag targets for my measurement, and I'm going to add the 2 targets that I measured. So I select the plus button on my screen, and then it'll automatically recognize any AprilTags that I captured. So if I hit select, you'll see live here that it recognizes those 3 tags. So I'm going to create 131 as a scale target, which means I only have a distance, not a coordinate for it, and create, and then do the same thing for target 137 as a scale target, create. Now the last thing I need to add is the distance between the 2. So on the right side, I'll press the plus button and set the distance between target 131 and 137 to 112 inches. So this is actually a hard constraint that's verifying your data and making sure that it fits exactly to that measurement. It very well may have already been, a perfectly accurate 112 inches, but depending on how you move through your scene, what targets you used, how large your scan is, this is a really great way to guarantee it. And as a result of it, improve the accuracy of every single point in your scan. So now I select next, and now I can close and optimize based off of that scale bar reference, which is taken into account as an additional constraint during optimization. So the AprilTags, even if you don't have measurements, are being utilized for loop closure. So anytime you circle back over these tags during scanning, they're going to be locked in as a known point that you've hit multiple times. If you reference known distances or known coordinates, those are going to be applied, similar to the planarity constraints Tom used earlier. This is all just additional information that's utilized during the optimization. And these tags are completely free and able to be printed directly from our website. And they can even be printed in different sizes. We typically will print out a full 8.5 by 11 sheet of paper, simply because the larger the tag is, the easier it is to get recognized. But you can even do them at smaller sizes as well. So now we can take a look at the outdoor RealSense data that was captured here on my phone and touch base on a couple other workflows that allow you to capture larger scenes using the latest software and hardware. So while we were able to measure the distance between these two tags, I also intentionally used 3 tags because this allows me to link multiple scans together on the fly. But before we touch on that, I also want to emphasize that with the latest hardware, you oftentimes don't necessarily have to link multiple scans together because you can capture much larger areas per scan, as we talked about during the presentation. So in order to activate this feature, if you're on one of the DPI-10 tablets, for example, which has the 8 gigabytes of memory or another powerful device, you navigate to Settings, Scene Size Settings, and you have this option to override the scene size limit. By default, it's set to a pretty cautious number based on what the software recognizes from your device, which will limit your scene size. You can expand that if you're confident that your device is capable enough. So you will notice though that there is this long warning before you start playing with this functionality. This is really important because depending on your software, what other applications are running in the background, etc., this can cause problems if you push it too far. So we highly recommend that if you're going to be expanding your scene size, that you run a lot of tests in a non-field environment with your particular hardware to make sure you're getting the results you need. And it's also worth noting that you're going to have to be a bit more patient with the optimization if you're scanning much larger areas in single scans. But in any case, we do recommend whenever possible to capture in one scan as opposed to 3 or 4 scans and linking them together. And this will allow you to push your single scene size limit up to 160 million points, although oftentimes you might be a little bit more comfortable putting it down to say 100 or 120. Say you've maxed out your single scene size, whether you're using that option or not, and you want to link multiple scans together accurately. In the latest version of Dot3D, you can now utilize the AprilTag targets as reference coordinates to link multiple scans together directly from within Dot3D. In order to do this, you would just go to File, and you have this option to export AprilTags. And what this does is it exports a simple text file that can be read back into Dot3D. So if I had another scan, going from the porch down the stairs in this apartment complex, it would link those 2 scans together and they would come up corresponding coordinates in recap, for example. So I select export. And the only thing you have to note here is that you want to make sure to check this box, simple format ID XYZ. And what that's saying is essentially keep this a clean, simple file that's meant to be read back into Dot3D and export tags. Once you've done that, then you could be pulling up your second scan, going to the targeting workflow, and then loading that target file back into Dot3D to be utilized as a coordinate reference and accuracy improvement for your next scan. So it's a very clean and simple way to link multiple scans together based on 3 coordinates that overlap. So that covers these 3 important AprilTag workflows and the use of an Intel RealSense outdoor capable depth camera on the back of a phone. We're going to be taking a lot of questions that have been coming throughout the session. But before we do, I'm just going to switch over to a couple more slides that are going to preview some exciting new features that are already in alpha stage and coming soon in the next releases of our Dot3D software. So now we're back to the presentation deck and touching upon a couple of these exciting new features that some have already hit the shelves and some will be soon. So first and foremost, Dot3D is becoming supported in several different languages, which is great for our international network of customers and resellers. So we're already supporting German and Mandarin in the latest release of Dot3D. And our very next update coming very soon will be supporting both Japanese and Italian as well. If you are a customer or reseller interested in working with us on adding more language support to Dot3D, please don't hesitate to contact us. Next, we're really excited to be adding multiple savable measurements to Dot3D. So as Tom demonstrated the measurement functionality earlier, it's currently, you can make as many measurements as you want, but you're only visualizing a single measurement at a time. This is essentially tying in the measurement functionality to the annotation functionality, where you can add as many measurements as you want and save them directly into that DotProduct DP file format. So as you share this data with third parties, they can actually see all the measurements that you made. This is something that's been requested quite often, and we're excited to be adding it into an update coming soon. Another feature that's come at customer request is the live annotation functionality during scanning. So while Tom demonstrated how you can annotate, directly on the point cloud immediately after capture on your tablet or phone, we're now able to actually capture those annotation points during the scan process with a crosshair functionality. So what this is doing is it's actually flagging those exact points while you're scanning, while you're in front of whatever the object is that you're going to want to make notes on later. And then when you get to your data review, it's going to allow you to cycle through each of those annotations, add all the relevant notes directly into your annotations. And this is a really powerful feature for tagging equipment in the field, issues that need to be addressed, etc. And those annotations will also be exportable into a text format for use in third-party applications. Lastly, we want to touch base on the exciting GNSS and RTK integration that we're building in to allow you to tie into your global location while scanning. This is a new feature that'll be coming in an update to Dot3D later this year, and it's giving you some location information as you move through a global coordinate system while capturing your 3D data from a device such as the DT Research 301X as shown here. And Tom, did you want to add any notes on the use of this tablet yourself? As I know you've had some experience with it.
So just stay tuned. We're going to have a webinar soon showing on how this was used in a crash reconstruction scene. The data went to court, and the prosecution prevailed using this data. But we'll have more details on that later. We're excited about this, though.
Fantastic. So bear with us for just a second or two as we switch over to pull up the array of questions that have come through. And Tom and I will both take these one by one in just a second.
While Chris is doing that, we had a question about whether or not we can connect this to a VR or an AR solution. And right now we work with AR Visio. AR Visio can read on the AR side, so they can read our native file formats. And we're looking at some others, very excited about those workflows. On the VR side, we work with WorldViz and IQ3. So there are good solid workflows for doing both AR and VR with our tools.
All right, so we got a lot of questions that came through. We'll start from the top and answer as many as we can. We also will be following up with direct responses to all registered attendees that ask questions to address these more specifically. And also worth noting, something I wanted to mention at the beginning of the session, while we covered a lot today and went as in-depth as we could in this short session, we also are happy to offer more customized and extended demonstrations of the technology for existing customers trying to expand their capabilities, or for new customers interested in this technology. You'll be getting a follow-up email with a recording of this session, and please feel free to respond directly if you're interested in scheduling a more in-depth demonstration. So as we move to the questions, we have, will this eventually use the LiDAR L515? This is likely answered through the presentation, as that was the Intel sensor that was previewed as a coming soon support. So how much time did it take to scan the deck? I think that is referring to some of those screenshots of the much larger area scanning that we showed. Tom, do you want to take this one?
So what was the question is, what was the size of that deck?
I think it was approximately how much time it took.
Oh, it was of order of 10 minutes.
Makes sense. Next question I'm looking at here
Not
is
more than 15. I wasn't on site, but that's what I recall.
Absolutely. What are the limitations with phone scanning? Since that was my demo today, I'm happy to take that one. In some ways, there are none in terms of the software. As with most applications you utilize today, they're functional on phones as much as any other piece of hardware. Very powerful today. But the limit is in terms of the sensors that are compatible. So today, that's the Intel RealSense cameras. So you're not going to be able to take advantage of a calibrated DPI device from a phone, but you can utilize calibrated D415 for indoor and outdoor use.
We've also not integrated the GPS capabilities in phones yet. That's a current limitation.
Sure. Next question is if the D43, if we support the inertial sensor in the D435i. Not currently. This is something that definitely may be added in the future for some improvements to tracking, although we obviously already have our own built-in tracking mechanisms. And the main reason why this hasn't been implemented yet is because we are still recommending the D415 over either version of the D435. Will there be support for Apple products? A couple questions about the LiDAR camera in the new iPad. This is something that is to be determined what exactly the capabilities are of that hardware, but it is something that we're excited about and are looking forward to testing with. But as it stands, it's Android and Windows supported platforms. The question, Tom, was for the room scanning just shown. Do you need a dedicated light source?
You can capture data in fairly dim conditions, but we strongly recommend having the light kit attached on top. It's a couple $100. It's very modestly priced, and it really makes a big difference. You can actually capture in complete darkness. Tracking's not as good, and obviously you lose the the RGB, the color values, but can be done. Related to that, we had a question about the camera resolution. For the still images, that's very much a function of the camera that is on the tablet. In the case of the Surface Go that I'm using, the max resolution is 3,264 by 2448 pixels.
So next question I see here is the cost of the phone camera. So this may have been answered during the presentation, but that would be the Intel RealSense D415, and the cost ranges from $150 to $500, depending on if you want to include calibration, mounting, and cables. Do you find that you have to recalibrate the Intel cameras after they've been out in the field a while? This generally corresponds the same as with our DPI devices. We do not generally find that they need to be recalibrated very often. Our concerns along recalibration would generally just come if you drop the camera, on a hard surface or anything along those lines. Then you should run some tests and potentially recalibrate.
Yeah, there are no moving parts. There are no bearings to wear out, nothing to seize up, no spinning mirrors. So the calibration tends to be very stable. Of course, if you drop the device, as Chris mentioned, all bets are off.
And we do understand from a couple of these comments here, I guess the audio cut out a couple times, apologies. Not sure what would have caused that, but it sounds like it was just for a short period of time. So one of the questions here around that time frame was, is it better to have green or yellow? The simple answer there is green is best, yellow is still good. And areas that you see turning gray while scanning have been captured to a lower quality. So you want to have green or at least yellow of anything of particular importance.
There are some subtleties to that question, though. If you're capturing a fairly large scene and you can do a loop, what the rookie does in our experience is moves very slowly around the scene, paints everything green. And our experience is that we get better results if you move quickly around the scene, get a coarse view of the scene, do a complete loop, and then go back and fill in the details. And you get a better result that way. And the reason for this is that you accumulate less frame-to-frame stack-up error. You have fewer frames, so there's less stack up of the frame-to-frame error, and you can go back and fill it in. So this allows the optimization routine to wring out that frame-to-frame error if you have a loop. So yes, get it green, but you may want to get ideally you get a coarse view of it first, and that may be yellow, perfectly adequate. This is something that does come with experience. But please resist that temptation to move very, very slowly around the scene, paint everything green, because you won't get the results that can be achieved using the other technique.
Next up, we have, does this microphone work for annotation? We currently don't support voice commands, but this has a feature that has been requested before this and is on our radar to hopefully add in the future. Can you figure out the diameter of pipe sizes or pipe sizes? So our software and our annotation feature will actually give you diameter, radius, and length of pipe measurements for any pipes that you flag after you've taken your scan. If you hit the limit and need to make multiple scans in the field, will your software stitch them together? So this is what I touched upon in my demonstration on the phone with the AprilTags. So this is an exciting, easy way to stitch multiple scans together using AprilTags. Or you also have the option of third-party workflows for stitching scans as well, similar to what you might utilize for other traditional laser scanners.
We also have the append workflow where we can add new data to existing files and stack them up that way.
Yeah, and the append workflow doesn't even necessarily require targets and still allows you to link multiple scans together. How would you combine these with DSLR as a presentation? So this is, you know, similar to the photos that Tom took while scanning and the annotations that he made. You actually could take even higher resolution imagery that you captured with another solution, such as a DSLR, and add them as 3D annotations in your scan. So you can select that object in your scan and attach those high resolution photographs to that location, and then you can cycle through them showing the 3D viewpoint of the annotation as well as the high resolution DSLR imagery, which would make for a great presentation. This is a good question. Some targets are located in the scan scene. Are targets required, or are they a tool to assist the software? That summarizes it pretty well. They are not required, but they are a tool to assist the software. The simplest way to put it is that even if you just put one AprilTag down at the start point of your scan and you finish back at it, something as simple as that with no measurement or manual input required is going to improve the quality of your scan. So they're recommended to whatever degree you have the time or capabilities for, but especially for smaller scale scans, they are definitely not required. What's the max scan that you can do? So this is a moving target, again, because of the capabilities of the hardware continues to expand, but it's also a moving target in terms of the answer because it totally depends on what type of area you're scanning and how much detail you need. So if you're just trying to get a floor plan, for example, and you're just capturing the floor itself, not the, objects, equipment, furniture, ceiling, walls, etc., you're going to be able to capture a much larger area. But assuming that you're capturing, a furnished environment in full color detail, we're up to the point where we can scan up to 3 to 5 medium-sized rooms in a single scan, or maybe up to 2,000 square feet potentially. That all depends on the hardware and environment that you're working in.
Let me weigh in on that one too, Chris,
Sure.
because we've had customers try to do some very large areas, 20,000 square feet. And, the results have not been great unless you have some way of locking it down with survey control. You're going to be disappointed. There's just sensor drift that you run into. We can do areas that are, 100 square feet or, 10 square meters, 500 square feet all day long, every day, and get very, very consistent results. Once you get into larger areas, you really need to be looking at other ways of locking the data down with survey control to reduce drift, particularly if you need corner-to-corner measurements. If you're doing a 2,000 square foot house and you want to measure the distance from one corner of the house to the other, unless you have survey control, you're not going to be happy with the results. But if you just need, room, within the room, you're going to be very happy with the results. So I hate to say it depends, but a little thought about this in advance is gonna really help out.
So next question here, is there a free viewer that supports the annotations and photos? So definitely. There is a version of Dot3D that's called Dot3D View. It's totally free, and it includes all the viewing functionality of somebody who has sent the data to you utilizing either Dot3D Pro, as we were using today, or Dot3D Edit, which is an edit-only version of the software. So definitely and currently supported on Android and Windows. What is the minimum setup for doing small-scale architectural measuring? So the absolute minimum solution to get set up with 3D scanning would be a RealSense camera for as low as $150 and a license of Dot3D software. We do have a Dot3D scan version, which is even more affordable than the Dot3D Pro version. And the limitations there, however, are to only small scale scan areas. Not only, just as a tactical limitation for the lower price version of the software, but also because it doesn't include a lot of the advanced functionality that I demonstrated today, such as AprilTag targeting for scale bar references or for coordinate system and linking multiple scans together. So a RealSense, a compatible phone or tablet, and your choice of Dot3D Scan or Dot3D Pro.
Just a little bit about the Dot3D Scan. I, don't want this to be a sales pitch here, but pricing. Dot3D View is free. Dot3D Scan is available by subscription. It's about $250 a year, just under. Dot3D Pro is available as a annual subscription for $1,000, and is also available as a perpetual license for $2,500.
Thanks. We've gotten a couple questions about if the annotations can be carried, and the HD photographs, for example, can carry over into third-party applications such as Recap. We do have a long list of partners who have implemented our software DLLs to read the DotProduct DP format directly into their software. And the latest version of these DLLs that we've recently published does allow for these notes, annotations, etc., to carry over into third-party applications. We're working with our partners to implement that, however, since that's a new feature. So as it stands today, those are carrying over into Dot3D across applications, and we're hoping to get them carried over into third-party applications in the future.
Yeah, right now the linkage is a CSV file. It is constrained. We're very hopeful that some of our partners will pick this up and ingest the annotations, measurements, photos, and so on directly.
Sure. Next question here, Tom, that I think relates to your demonstration today. When you're picking planes, do you have to pick the same plane, like the same floor, or can you pick different planes that are maybe parallel to each other?
So you can pick the same. It doesn't optimize today based on parallel planes. But I can pick, a wall, a floor, the same wall somewhere else, the same floor somewhere else, and the software will figure out that those planes need to be made parallel. But if I have two opposing walls that are, parallel in that sense, then no, you only get the constraint working on a single wall, on either of the walls.
Question about the design compare function. We will follow up directly via email with some more examples of that. Wasn't something we had a chance to show today. A question here, can Chris add the second scan to the first and show the AprilTag influence? Definitely. Actually, I had a second scan prepared, but given the time constraints of the webinar, chose not to show it live, but I'll follow up with it with an example of two scans linked together based on that overlapping 3 AprilTags.
Chris, when we send out this video, perhaps we can have an appendix to it with some follow-up material, supplementary materials, and that might be one of the things we can show in Dot3D.
Absolutely. So what is the best output format to preserve measurement when importing point clouds to Recap? Typically, we find that working directly in the native .dp format is your best option when you're working with solutions that offer that as an option, Recap being one of them.
Yeah, the measurement units are preserved in the Recap file that we export, so Recap knows what it's getting, and Recap itself can read our binary DP files and also keep the units straight. The binary DP files are always in millimeters, but we work with tools that that prefer US survey feet, for example, and the handshake between our application and other applications is very, very solid.
Next question here is, how long does it take to go from new users to competency on the job site? This is something we definitely take pride in. Even our paid training sessions are typically, half a day or at most a full day, and that covers a lot of extensive functionality. And that's for a full training session. That's not always necessary. One of the big benefits of our technology is that, it's very easy for one experienced user to train another user on the fly. And it's not something you have to, by any means, be a certified expert in order to operate. So you could get someone from a new user to competency in a matter of an hour. Obviously, the longer the better, and certain best practices can make a big difference, but it's definitely a unique situation that we do take pride in with our solutions.
Let me just weigh in on that a little bit too,
Sure.
Chris. We've had a couple of experiences where customers have ordered the equipment, and the first time they see it, they're opening the box on a job site, and wouldn't recommend that. It's good, but we're not there yet. Where it's instant on. But I trained some crime scene investigators recently at a conference. We had a 2-hour workshop, and we spent the first hour talking about how the device can be used and the software, and we spent the second hour doing some practical hands-on scanning. And by the end of the hour, the second hour, everyone was able to capture data. So it's a pretty short on-ramp.
Next up, I see, how does this work in a stainless steel or otherwise reflective objects? Again, it is generally a particular benefit to our technology given the nature of the real-time feedback. You're not going to be able to capture a truly polished mirrored surface or a transparent window. But outside of those two situations, stainless steel, somewhat shiny or dark black objects, you're often able to fill in better than most other capture solutions because you can see, oh, I see it struggling a little bit with that surface. And you just get it from a little bit of a different angle or distance, and at least 9 times out of 10, you're going to be able to fill it in. So it does pretty well, in particular with stainless steel, unless it's a polished mirror. Where can we get a template for the AprilTags? That would be dotproduct3d.com/targets. You can download them directly there and print out as you see fit. What is the absolute accuracy of the DPI-10? Absolute accuracy doesn't exactly apply to mobile scanning solutions because who's using it and how you're moving throughout the scene and the size of the scene you're capturing can all vary. But we can tell you that in close range measurements or in reference measurements across larger areas, you're able to obtain accuracies as tight as 2 to 3 millimeters. And that's the best answer we have for that. That relates to close range measurements or measurements that have been referenced to known constraints.
I'll just add a couple of things to that, Chris. The way we express accuracy, and it's the way you do it for structured light devices, is it the percentage of full scale. So with a calibrated device, it's of order of 0.2 to 0.5% of the full scale measurement. And I know that that's a little frustrating for people who are used to laser scanning, tripod laser scanning, where the accuracy is constant over the range, but it's just the nature of the beast. We've pursued this pretty hard. I went to our NIST in Gaithersburg, DC, and had a chat with them last year about accuracy standards for structured light measurement devices. And this is something that they're beginning to look at, how to come up with some protocols for establishing that, but it's very new. So what we've found best practices is if you need an absolute accuracy standard, put a reference measurement in the scene, okay, and refer to that. As I mentioned earlier, our data has been to court and presented to a jury, and having an absolute reference in the scene made all the difference. That was something that staved off the cross, stood up in the cross-examination. So it's got some subtleties to it, the question, and I know that's frustrating for some of you. Happy to have a longer conversation about that.
Where do I find the calibration file? So with all of our latest solutions, whether that be a DPI-10 or a DP calibrated RealSense kit, Your calibration file will be delivered via email and can be loaded directly into Dot3D from the Settings tab. How long do the new light kits last for the DPI-10? The battery life, based on our testing, is up to an hour and a half to 2 hours of continuous use. We recommend turning it on and off when you're doing multiple scans to extend that. And then you also now have the hot swappable battery pack, which is included in the kit. So that can double that and allow you to charge while using the other pack to extend it further in the field. Can you annotate and export details into a CSV file to get into an asset management survey? Tom, can you speak to that? I know this.
So we can export these, and we'll follow up with you directly on the best workflow for doing that. This is something that is of high interest to us, and streamlining that workflow is something that we would welcome a longer conversation with you about. All of the pieces are in place to do this.
Next up, we have in which version will the multiple measurement function be released? We're excited to announce that this will be available in Dot3D 3.4. So please stay tuned for that release this year. Question about getting the scan data into SolidWorks. I would recommend taking a look at our knowledge base at dotproduct3d.com/knowledge base, and in particular, the article on 3D meshing or solid feature extraction, because generally with any 3D scanning solution going into SolidWorks, you're going to have to perform some sort of a conversion. So that's converting this to a 3D mesh or a solid model, either manually or semi-automatically for use in the SolidWorks platform.
We've solved the limited case for planes and cylinders. So if you have prismatic geometry, it's possible to extract those as simple features. We use a tool from Elysium called InfiPoints to do that. It's an option on our Android devices. And that exports an IGES file, which can be read directly into SolidWorks, also DWG. But if the surfaces are curvilinear, then you're looking at meshing, as Chris mentioned. That's a longer conversation. We'd be happy to follow up with you directly on that.
Next up, question is, does the Android version export RCS? Unfortunately, no, it does not, but you do have a couple options if you're operating on Android and you want to get to the RCS format. One would be that Recap will read in the DP format directly and export RCS from there, so that can be your conversion even in the free version of Recap. Alternatively, you can add a Windows license of Dot3D for as low as $12 a month for edit-only functionality. So that can be your conversion tool. So either of those are an easy way to get to the RCS format, whether you're if you're working on an Android tablet or phone.
What's behind that is that the SDK from Autodesk is Windows only. It doesn't work on Android. So exactly. That's what the constraint is. I do want to circle back to the multiple annotations question, Chris, just for a second.
Sure.
We're very interested in working with you on a beta basis. We'd be happy to get you a beta license of the software to test out these functions, and if that's of interest, please contact us directly, and we'll get you set up with a beta license for that.
Do you have an example of a point cloud in LAS or RCP format? We definitely have some examples. I'd recommend going to dotproduct3d.com/sample data, or otherwise, we will be responding to these questions one by one as well. Be happy to share some sample data. It's also worth noting that if you download any of our sample data in the DotProduct.dp format, you can activate a free trial license of Dot3D, which allows you to export to any of our supported formats, which include LAS and RCS on the Windows platform. This is a good question. Next up here, while scanning, do we need to go slow over the area to get a good scan? Because I go very slowly trying to get everything in green and yellow, but I always see you go pretty fast, for referring to demonstrations like today. Don't we need to go that slow to get better quality? This is in many ways a common misconception for new users. We find that not only going too slow or getting too close are natural instincts when using this technology. and that's not necessarily the case, especially if you're trying to capture larger areas. You really just want to follow that green and yellow feedback as a guide. And also the software will prompt you if you're moving too fast. So don't feel like you need to move crazy slow. Obviously, you don't want to be moving crazy fast either. And you also don't necessarily want to be too close. That'll cause issues with losing tracking if you're getting really close, and is in many ways unnecessary. Like usually the sweet spot, whenever possible, is about a 3 to 6 foot distance and a medium pace.
Yeah, let me just add to that, Chris. You
Sure.
know, the closer you are, the less range noise. So in some sense, the more accurate you get with measurements. However, if you get close to anything, it looks flat and it looks to be the same color. So you lose tracking ability. So these are somewhat offsetting each other. You want to be far enough away. You want the camera far enough away from what it's looking at so that it can see enough geometry to track. You want it close enough to minimize the range noise. So they buck each other. And with the, yeah, as Chris mentioned, the sweet spot is in that, 4 to 6 feet, 4 to 8 feet, that kind of range. And if you have areas that are of high interest, equipment tags or, subtle geometry variations, then you want to zoom in and get closer. But nearly always the best strategy is to go around, do a coarse loop, get through the scene fairly swiftly, and then go back and fill it in. And let our software do the optimization. And if you don't have enough detail, you can append, you can go and add more data. Rather than, laboriously, painting everything green, slowly moving around the scene.
Can we do modeling using the output cloud? I mean, is it reliable to do modeling? In my opinion, absolutely. And the caveat there is as long as you're keeping it within the scale of what handheld 3D scanning is suitable for. It's not the solution that you use as a standalone tool to model an entire building, but entire rooms, multiple rooms, absolutely. And it's generally the same sort of workflows that you would use with a larger scale 3D scanner, similarly hand in hand potentially for larger building modeling.
So Chris and I had a project recently. I think we showed you some photos from it. It was this engine room, and the data was used to model changes to some engine mounts. So the steel. So it informed a ship constructor model, which is an AutoCAD add-on. Absolutely, we're able to do that. Would you use this tool to reverse engineer a V8 engine? No, this is not the right tool for that. You would be really disappointed in the resolution and accuracy. So, it just depends on the scale and the accuracy requirement, the tolerances that you can live with, on the appropriateness of this for modeling.
Next question here involves customers and owner of the DPI-8X, and if Dot3D Pro is compatible with our older models. A twofold answer here is yes, it is compatible with all of our past models of DPI-8 variety, and definitely recommended. You'll get a lot more out of your device if you upgrade to the latest Dot3D Pro. This would require an active support and maintenance plan. So if you haven't stayed up to date on that, you would want to renew that. But otherwise, that's it, and you're able to update to Dot3D Pro. Secondly, it's also worth noting that we do have hardware upgrades available if you want to convert your DPI-8X or DPI-8S, for example, to the latest and greatest DPI-10, add that larger scene capture, add that RealSense compatibility, etc. As well as the latest Dot3D Pro. We have hardware upgrade paths, so definitely feel free to inquire about that. So one final question that was touched upon in several different variations here was regarding the L515, the new camera coming from Intel, and what that's going to bring to the table. I would say that we're excited about it. We do think range extension will be a possibility. What we can say so far, although, is that it will be an indoor camera as well. but we're not going to talk about it too much until it's something that we've run further tests on and are preparing to release. So yeah, it's coming soon, and as soon as we have more information, we will make it available. All right, so I think we'll cut it at the 1.5 hour mark here. And thank you everyone for joining today and asking a lot of really great questions. And we'll be in touch with you directly via email. And everyone on here will be receiving a recording of the webinar. So please stay tuned for that, likely tomorrow or by the end of the week.
Be safe, everyone, and thanks very much for joining us today.
Hi everyone, Chris here, back on my phone for a quick addendum to our webinar recording from yesterday's session. Just wanted to quickly demonstrate a few things that we didn't get a chance to show during the live webinar and that we had a couple questions about. So first off, I have my scale bar optimized data set here and just wanted to quickly demonstrate the precise 112-inch measurement that has been referenced between these two AprilTags and is therefore applied to assist in the accuracy of every point in your scan. This is a sample using just a single measurement on the longest length of this particular scan. It's worth noting that if you were scanning a room, you typically would want to have at least 3 scale bar measurements to cover the length, width, and height of your scan. Next, the primary purpose for this additional video was to show the registration workflow between 2 scans using these 3 AprilTags, assuming that there's an overlap between all 3 tags between 2 scans. So as I showed yesterday, I want to first go to the File, Export AprilTags function. I'll name it Demo Tags 48. Okay, and then I want to make sure to check the Simple Format button and make sure my units are correct. Now I'm going to back out and pull up another scan that overlaps with these same 3 tags. So as you see, this scan got the stairwell, but also has those same 3 tags on the deck. A more accurate example would be room to room, etc. But this is going to show the full workflow. So if I go to Edit Targets, use AprilTag Targets. Now I can select from the top right the Load/Save button, and I can load a control file, Demo Tags 48, OK. Units, inches, OK. And you'll see all the XYZ information for those 3 tags comes in and is going to be utilized to position my second scan. So I'll hit Next. It's fit all 3 targets successfully. I'll hit Next. And close. The scan has already been optimized in this case. And now when I go to export this scan or save it, I'll go to File, Save As. We'll call it Stairs with Targets, T for Targets. You'll see that I have the Output Transform option now available to me of control targets, so I want to make sure I use that and Save Scene. Now, if I bring that first scan and the second scan into Autodesk Recap, Cloud Compare, a wide variety of partner platforms that will read multiple scans in at the same time, these will both come in the same coordinate system and overlap with each other cleanly based on the registration via AprilTags.